So this is the asynchronous lesson for Wednesday, October 14th on lesson 4.3, day 2, or 4.3b. Again, we're skipping 4.3a or 4.3, day 1, because it's stuff that comes up later in the year. So just to save time, we're going to skip it, and we'll get to all that later on in the year. Okay, so I'm going to do this worksheet in a slightly different order than normal, especially because you don't have breakout groups to talk things over with. So we are going to skip through the activity, do a part of the big ideas first. Let me just teach you something. And then I'm going to have you go back and do the activity, and then I'll finish out the big ideas. Okay, so there's kind of two separate learning targets here, two separate things that we need to finish up about experiments and sampling before we can call ourselves done with chapter 4. So learning target number 1 for today's lesson is around the idea of inference. Inference. Okay, so this is actually a really big word in this class, and it is what we do almost all the second half of the class, or all different versions of inference. So remember that you have a population, so that is everybody that you want to know information about. And if you're able to ask everybody in the population, that's a census, and that's great, but that's oftentimes hard to do, especially if your population is big. So instead, what we are capable of doing is getting a sample, a small group from that population. We collect data on that sample and then use information about that sample to make conclusions about the population. Okay, so that act of like taking a sample and saying the conclusions I got from the sample are therefore true for the whole population, that is inference. You're inferring things about the population based on what you saw in the sample. Okay, so part of the goal today is to talk about the two different random things we've learned in this chapter and kind of making sense of how they're different and how they're the same. So we spent a lot of time talking about random samples, which is different than random assignment. So we had random samples and random assignment. They both used a random number table to do things randomly. A random sample is about who you get in your experiment or who you get in your observational study. What experimental units are you going to look at? Deciding who or what is in your sample is random sample. And random assignment is in experiments. Once you have your sample, once you have your experimental units there, randomly assigning them to different treatments. So a random sample doesn't have to be an experiment. That could be an observational study. And it allows us to generalize to the entire population. And by generalize, I mean whatever conclusion we make about our sample, we can infer that same conclusion onto the population. So if it's a good sample, a good random sample, we can say what I saw in the sample is what is true in the general population. Okay, random assignment. So once you're in, you have all in an experiment, once you have all your experimental units there, now deciding who gets what treatment, that separately is the cause for a good experiment. And the purpose of it is to wash out all the confounding variables and leave it down to just the variable that you're controlling for. So it allows us to make cause and effect conclusions. So random sampling allows us to generalize about an entire population, say what I saw in the sample is therefore true for everything in the population. Random assignment within an experiment, when you're randomly assigning treatments, that allows us to say that this variable is causing this response. Okay, so that's that. Now I want you to pause the video and go back and do the activity on the first page. So numbers 1 through 4, try out those 4 examples and try practicing coming up with conclusions based on what you know there. being careful to keep straight random sampling versus random assignment. So go do the first page, then unpause the video and you'll see me going over it. Okay, so let's go over that first page. So the first example, there was not random sampling and there was not random assignment. So there's no ability to do any inference at all. So there's no inference about the population or causation. At this point, all you can talk about is what happened in that sample. So for students in that class, all the people in the sample, you did see a relationship, but you cannot assume that's true of all students. You cannot assume that's true of all people. And you cannot assume that listening to music caused the lower GPA. Okay, number 2, it was a random sample now, so it's getting better, but still not random assignment. So you can make an inference about the population, but not about causation. So because it was a random sample from the school, the population is the school now. You can say this conclusion I saw in this sample is true for the entire school, not just for the sample of students, because it was a random sample. Okay, number 3, not a random sample, but there was random assignment. So it was only students in your class, but at least they got randomly assigned to treatments. So this one only allows inference about causation. You cannot assume that the results of this experiment will be true for everyone in the school, but at least for people in that class, you can say, yes, listening to music while studying did cause the lower GPA. Now, number 4 is when everything is going the way it's supposed to, and you have a random sample and a random assignment. So now you have the ability to make an inference, to infer things about the population and causation. So this is what you're hoping for. You did a random sample of people in your experiment, and then once they were there, you randomly assigned them to different treatments. So you can say, for the entire population, for all the students at your school, if you listen to music while studying, that's going to cause you a lower GPA. Okay, so now I want you to pause the video and go do the check your understanding. And once you put your full effort into that, oh no, back up. Oh, I'm lying. Forgot the other learning target. Because this did not show up in the activity, but it will show up in the check your understanding. Okay, learning target number 2 is, truthfully, really important. Data ethics. So there is a lot of issues around what is an ethical way to collect data. And how do you make sure that your experiments are always ethical? Okay, so there's kind of 3 things that need to be true. I can't talk while I write this so I can spell correctly. So institutional review. And what they mean by it is that it's not a just random person off the street running an experiment. It's not your uncle making you do something to see what happens. It's not, it is actually an experiment that is set up by a certified group of people who are experts in how to run good ethical experiments. So it is subject to institutional, there should have been an AL, institutional review. Some institution is doing it, not just anybody. 2, there needs to be informed consent. Informed consent, assuming we're talking people. Clearly, if you have an experiment with plants, they don't need informed consent. But if people are involved, they need to know they're in an experiment, and they need to be okay with the fact that they're in an experiment. They've given their consent to be in an experiment. And the third one is that it needs to be kept confidential who is in the experiment and what happened. So if someone gives consent to be in an experiment, that does not mean that they are giving consent for all of the things that happen in the experiment to be broadcast to the world, at least not connected to them, that they will stay anonymous. They will have privacy around the issue of however the experiment went and that they were in the experiment. So I could tell lots of stories about different unethical experiments that didn't fit these. Things like the Tuskegee syphilis experiment. That would be a great thing to Google. Where a group of doctors back in, like 1910s or something, early 19th century, no, early 20th century, started a review of Black people who had syphilis and were following their symptoms. And then it was a long study that lasted like 30 years. And partway through the study, doctors, the medical establishment came up with a cure for syphilis. And these people that ran this experiment did not tell the people in the experiment that there was a cure. In fact, they purposefully hid it from them so that they could watch their symptoms continue and see what happens to them, like track their progress until they died. And so crazy unethical, right? So that's an example of those people did not consent to be in an experiment where they consented to be in the experiment, but they did not consent to not be told there was a cure. And honestly, that went under an institutional review at the time. I would certainly hope that an institutional review of today would not go over that. We talked a little bit about how the smoking companies, the tobacco companies, say that it's never been proven that smoking causes lung cancer. And that's because no one would consent to being in an experiment where they're forced to smoke. So anyway, data ethics. Okay, so that's going to come up in the check your understanding. So pause, go do the check your understanding, and then unpause and check your answers. Okay, so on check your understanding, this first one, there is no random assignment and no random sampling. It's just the people who happen to get hurt and got removed. So you can't make an inference beyond just that sample. All you can say is those particular athletes were less likely to recovered more quickly if they got removed from play. But we don't have the ability to say that's true about all athletes. And we don't have the ability to say that removing them from play caused them to recover quickly. Would it be ethical to conduct an experiment? No, because you can't be like, I know you have a concussion. You need to get back out there on the field because you are in treatment too. Like, you can't do that, right? Like, that would be unethical. So number 2, so no random assignment here, so we cannot show cause and effect. And it would not be ethical because, I mean, it's the mothers, but it's also the babies receiving this treatment, and they have no ability to give informed consent. So there you go. Okay, so that is the last lesson in chapter 4. So turn this paper in for your classwork points. And remember that tomorrow, Thursday, is review day, and Friday is test day. All right, that's it.